morning, students. I think today we are going to conclude this short chapter, which was their kinetic theory of gases. We have discussed what is the degrees of freedom in the last class. Our today's main discussion is the law of equipartition of energy. First, in our syllabus we have to discuss mainly its statement and its application in the various things. So let us see law of equipartition of energy. This is the law of equipartition of energy. It is the law of equipartition of energy. And if we want to state, I have written the statement. It states that in any dynamical system in thermal equilibrium, that means two things have been said. In any dynamical system means the system in which the particles or the molecules are in the motion, and the system is in thermal equilibrium. You also know what is the meaning of the thermal equilibrium. Means its exchange of the heat with the surrounding is zero. No exchange of heat with the surrounding is taking place. In thermal equilibrium, the energy of the system is equally distributed amongst its degrees of freedom, various degrees of freedom, and energy, this is very important, energy associated, look, it's very important, energy associated with each degree of freedom per molecule. That means 1 degree of freedom per molecule is how much? Half kb into T. Kb is the Boltzmann constant, T is absolute temperature or the temperature of the absolute scale. This underlined thing is very important. Energy associated with each degree of freedom is per molecule is half kb into T. This is the statement of the equipartition of energy, law of equipartition of energy. I want to use, mainly in our syllabus, I have to use it applications in case of specific heats. We have to use it the specific heats of number 1, monoatomic. Let us use it in case of the monoatomic gases. I know, or we know that monoatomic gases means, monoatomic gases का मतलब होता क्या होता है? Means it is for the helium, neon, argon, etc. So monoatomic gases. Now what I do, dear students, in case of the monoatomic gases I am doing in detail. Then in diatomic and in triatomic we can do in shorter way also, like this. According to equipartition of energy by the law of equipartition of energy. I just tell you, energy associated with each degree of freedom per molecule is half kb into T. Then energy associated with 3 degrees of freedom per molecule is 3 by 2 kb into T. Because you know, in case of the monoatomic gases, there are 3 degrees of freedom. That's why 3 by 2 kb into T. Then energy associated with 1 mole of a gas. Monoatomic gas, how much it will be? 3 by 2 kb into T as it is into Na. The Avogadro's number. Here, you know, Na is the Avogadro's number. इससे मैंने मल्टीप्लाई कर दिया, ठीक है? Then what is this? Can we say that this will be equal to this is equal to 3 by 2. A kV into Na is R into T. Here I write here R is equal to kV into Na. Look at this. We are getting this much. Okay, fine. This is now 3 by 2 RT we are getting in this case, that is 3 by 2 RT. I can write this as here U is equal to 3 by 2 RT because U is the total internal energy in this case by first law of thermodynamics. What will happen? dq is equal to du plus pdv. At constant volume, pdv is 0. So du is equal to dq is equal to, if I take 1 mole of a gas, then 1 into, I think you know, it is Cv into dt, provided its temperature is increased by dt. Okay, then what is Cv? Cv is equal to du by dt, d by dt into d by dt of 3 by 2 RT. How to differentiate? 3 by 2, R is a gas constant, you all know, and dt into by dt is 1. So Cv is equal to this. Now what will happen? Cp is equal to Cv plus R. You know Mayer's formula already we have done. Cp minus Cv is equal to R. So how much you are getting? 3 by 2 R plus R means how much? 5 by 2 R. So gamma should be Cp by Cv. It is the ratio of the two molar specific heat capacities. It will be 5 by 3 means 1.66. Look, with the help of the equipartition of energy, the principle of equipartition of energy, we got the value of gamma, Cp, Cv and gamma like this. Now, if I do it for second one, suppose as I told you that first case I am doing it in detail. Second case, no such detailed explanation is needed in case of the diatomic gases. यहाँ पे देखो मैं थोड़ा सा स्टेप बता देता हूँ. यहाँ पर भी तुम बोलोगे एनर्जी एसोसिएटेड विद ईच डिग्री ऑफ फ्रीडम इज दिस. ओके, हियर 5 डिग्रीज ऑफ फ्रीडम. सो यहाँ पे इन शॉर्ट एनर्जी associated with 5 degrees of freedom per molecule is how much? 5 by 2 kb into T. So energy associated with 1 mole of a gas, okay, 5 by 2 kb into T into Na means here U is equal to how much you are getting in this 5 by 2 RT. Then what is Cv? That is du by dt is d by dt of 5 by 2 RT. How much? 5 by 2. Then what is Cp? Cp is equal to Cv plus R 5 by 2R plus R 7 by 2R. So gamma is equal to Cp by Cv. How much? 7 by 5. How much? 1.5. In short, I have done it. You just follow this one first. In this I have written each and every step. But in the examination, if you are asked for diatomic, then you will write all these steps. But here I have not repeated this first law of thermodynamics and all. I have not repeated. Okay. Similarly, if you come to the triatomic one, if you take the case of triatomic, in triatomic number 3, because in our syllabus mainly we have to discuss only these triatomic gases. If we want to discuss what will happen in the triatomic gases, look, in case of the triatomic gases, there may be two types of the degrees of freedom. I hope you are remembering. One is the 6 degrees of freedom or 7 degrees of freedom. I can write here either 6 degrees of freedom, okay, or here, or 7 degrees of freedom. दोनों में हो सकता है. So proceeding according to the same way, what we shall get in this case, we shall get CV is equal to 6 by 2 R, and here we shall get CV is equal to 7 by 2 R. Okay? So what we shall get in this case, CP is equal to CV plus R means 3R plus R means how much? 4R. So CP by CV, then gamma is equal to CP by CV is equal to 4 by 3, because this is 3R. 4 by 3 means 1.33. And here what will happen? Exactly in the similar way, CP is equal to 7 by 2R plus R, that is 9 by 2R. So gamma is equal to CP by CV, that is 9 by 7. You can get it, 9 by 7. That means this I have done it in very short. First one I have done in very much detail, second one में थोड़ा सा short कर दिया, third one को बहुत short कर दिया. इसमें दो तरह का आ सकता है. In one configuration this is, and in another configuration this is, because in triatomic two types of the configuration of the molecules are possible. This is all about the equipartition of energy and its applications. Alright?